Hello, hello everyone. Welcome back to our platform again today. The platform is Siva Tech Space, guys. We created this to deliver some of the interesting innovations or some of the new trending innovations that are going on out there in the tech industry. So over here we do have multiple hosts that will sometimes come on this platform. Some of them are software engineers, some of them are cloud engineers, machine learning and AI, uh, artificial intelligence engineers, guys, and robotic engineers as well. So, and today I am the host on this platform to deliver for you this lesson. So this one today we are going to be talking about uh, the following things. My name is Paul, like I talked about, and I'm a DevOps engineer and also a business owner. I'm also an agile practitioner, guys. So, and then looking at some of the things that we'll cover in this video, we are going to look at some basic things. The title says we are going to do deployment today of clusters. We are going to deploy a cluster today, EKS, on AWS platform. But before we do that, we want to also like just look through some of the basic notes around Kubernetes. We'll look at what is Kubernetes, and then we'll look at the basic architecture and deploy our cluster using the kubectl commands from the command line, and then we are going to go ahead and write our manifest file, a deployment manifest file, and go ahead and uh, deploy uh, the uh, the deployment, automate the deployment using using the declarative manifest file that is going to be written in YAML. So let's go ahead and see exactly what Kubernetes is, guys. So I just want to let you know that if or before we go into technical details, let's understand that Kubernetes sometimes is abbreviated KAS, and it's a powerful tool, right? It's a powerful container orchestration tool that automates deployment, scaling, and management of our containerized applications. Okay, that is what Kubernetes is. We understand that Docker has been doing an amazing job building up our containers, but it has some limitation that it can't auto scale the containers, as well as maybe sometimes not capable of managing large containerized applications. Sometimes we're talking about thousands of containers here, guys. So it can be difficult, and it's also Docker doesn't have that self-healing capabilities. So because of that, you can sometimes have a downtime with your containerized application. So those are the problems that Kubernetes is here to take care of. So in the past, this is the kind of technology that organization had leveraged in the past. So usually uh, they will have a host server. This is just the kind of architecture, right? The architecture that organizations had used in the past. Even some organizations are still using that today. So typically they will have a host server. That host server may have its own operating system and CPU, the RAM, the memory, and all the resources, right? And then off of that, they will install a hypervisor. Okay, the hypervisor is just um, that software that you get to install that between the host, uh, the host hardware and the virtual hardware, okay, so that you should be able to uh, introduce some other operating system, because you have some application that you want them to run just on Ubuntu servers, or maybe on a CentOS virtual machine, or Mac OS, or the Red Hat, or Debian. So it's going to depend on you. Okay, so usually you will need a hypervisor to install on this hardware, then before you can make that provisioning and introduce those guest operating systems. So when that happens, you'll find out that containers, your applications are going to be running on VMs, right? You have your application running on VMs, and sometimes it's super costly to run your application on VM because it requires a lot of resource utilization. Okay, and so that is why container technology has come, and many organizations out there are currently trying to leverage containers technology because it's super less costly to manage your applications or launch your applications on those containers compared to launching your applications on VMs. So with container technology, you have your usual hardware, and off of that, we are talking about the typical on-prem situations here. Okay, guys. So this architecture that we have here right now, they are typical on-prem architectures. So we are going to go to the cloud architecture. Although we're going to be launching our cluster in the cloud, typically, particularly AWS. So, but right now, what we're doing right now, we are the architecture that I'm showing, demonstrating right here, they are on-prem architectures. So I will move on from here. So uh, in this situation, guys, so you have your uh, host operating system, and off of the host operating system, let's say it's Mac OS, you can run uh, containers, right? Docker containers off of that, and be able to host your applications on those Docker containers. And they host those host servers. That is, the containers are using resources still from the host server though, but the containers are just getting just the minimum requirement, just the minimum of the kernel, right, of the host operating system. Then together with its library to run those containers, and you can host your application with seamless effort. Okay, so rather than running on specific machines, you can do this and run the applications on containers, and those applications will run from multiple environments without any problem. Maybe the test environment, the staging, or maybe the production environment, right, without any problem. But sometimes with VMs, virtual machines, you have problems. Containers may run, application may run in some environment and may not run in some other. It may run in the testing environment and may not run in the production environment. So those are some of the problems. Then a little bit about the concept of container technology. Okay, some of the powerful software out there that you will hear about when it comes to containers technology, they will talk about Docker. Docker is a widely used container. Uh, you hear about it a lot, right? Before Kubernetes came up, Docker had been there a little bit older than Kubernetes, and has done an amazing job, right? It has done an amazing job provisioning of containers. You can build up images off of uh, Docker files, and then run containers off of the images and be able to host your applications without any problem. So uh, it had some limitation though. So some of the limitations that Docker could not do, some of the things that Docker could not do is that Docker could not self-heal. It didn't have a self-healing capability, so that if a container dies, Docker cannot automatically replace this uh, this container. Okay, so he also had another problem, which is scalability. He had a problem with scalability. It means that um, if maybe you have a specific number of containers that are running, okay, that are running at this particular time, and maybe the traffic increases on some of those other containers, and the load balancers has made a lot of distribution of the traffic as much as they can, and finds out that the CPU utilization is getting higher, and it doesn't have enough other containers to have some of the load distributed over those containers, then it's going to happen that Docker cannot produce uh, auto scale to make provision for those allocation of resources, right? So those are some of the problems, and because of that, you can have your application, you can crash and all of that. So with Kubernetes, so Kubernetes now is coming in, it's a container orchestration tool, okay, which is a very powerful tool that comes in to do automate some of the scaling, and also manage those large containerized application, because we're talking about thousands of containers here. So with Kubernetes, you can automate deployment, automate the scaling, and also be able to manage thousands and millions of applications, okay, just from the control plane. We'll see about that. Don't worry about that word control plane, guys. We'll see about that later. So there are also some other technologies out there. Talk about the Podman technology, also the Rocket, and the LED, okay, the LXD uh, container technology software, and then the OpenVZ as well. So these are some of the tools that you hear about it when it comes to container technology out there today. So now let's move forward. Okay, let's look at a little bit more into Kubernetes. So we are going to look at the architecture for Kubernetes. Okay, so this is the architecture for Kubernetes. This image is gotten off of the Kubernetes website, and that's from Google. Okay, it's gotten from Google, and then and so I just got it over there, and then I decided to get it just the way it is. I'm gonna try to explain a little bit about the architecture. So usually you have your control plane. Okay, you have your control plane, and off of your control plane you have API server and cloud controller. You have API server, you have controller manager, then you have the etcd. You also have the kubelets. Okay, the kubelets are on the nodes, and then you also have the kube proxy. The kube proxy are uh, the executors, right? They are the executors of some of the tasks that are going to be running on those nodes. Okay, and it's in the containers on those nodes. Let's put it that way. Then you also have the scheduler, and then the control plane, like we started talking about that. Okay, and then you need to be able to understand or maybe talked about your cloud provider. So this is a simple, well, I'll call it the simplest, right? The simplest architecture that you that is out there for Kubernetes. And and at the time when I'm making this video, this time is I would say, is it May 14? May 14, right? Of 2023, which is latest. So that's what I was able to get for the architecture for Kubernetes. So let's go ahead and check out a couple of terms, right? Let's check out a couple of terms that are off of this architecture. So when it talks about a pod, okay, I just talked about a pod. So what is a pod in Kubernetes, right? So you have to understand that a pod is the smallest unit, okay, of object that is being managed by Kubernetes. That is the smallest Kubernetes uh, object. Okay, and then each pod has its own IP address that is shared among the containers that are in running in that pod. Okay, so in a pod, you're going to have multiple containers that are running in that specific pod. So, and then you also have resources that are in that same pod that can be distributed among other containers. And that is it, a little bit about a pod. I don't know if I should demonstrate that. Let's see if I should be able to demonstrate that right here. So we are talking about uh, the master nodes, and also then you have the the I just talked about the master node, and I'm talking about the control plane. Yeah, sorry, I started talking about the master node like we are in like Ansible, but it's still fine. You can still call the master node, right? So, but in this case, I would like to call it the control plane. So, in a specific pod, let's say you have this like let's say a pod. So this is a Kubernetes pod. Yes, so this is like a Kubernetes pod. Then in this pod, oh, great. So in this pod, you're going to have like a couple of containers that are running in that pod, right? Let me see. Let's say you have the pod right there, and then you have a couple of containers. You have uh, in one pod you can have in some other pod you can have just one container running in the pod, and in some other pod you can also have like multiple containers running in the pod, right? So in that case, it's going to just be maybe a pod for the main, I mean, uh, container for the main application, and also and some other containers to host like other things like the manifest file. I mean, the libraries of the container, right? So yeah, so you can have maybe the main application running on a specific pod, and then you have uh, other containers. I mean, the main application running on a specific container, and then you have supporting containers that are carrying maybe it's just the libraries. Okay, and all of these are running in one pod. That's what I was trying to explain, guys. Sorry. So then, like we did talked about deployment. Let's talk about deployment a little bit. So a deployment is also another Kubernetes object, right? So it's another uh, Kubernetes object. So it specify the scale of the application, okay? The scaling or how the application should run. So usually it will contain, let's go back to the architecture, guys. Let me show you guys a little bit something here. So usually in a deployment, we'll be talking about the API server. You need to talk about uh, maybe the kind of deployment, right? Okay, the kind of deployment, which is, and then you talk about the specs, talk about the replicas. Don't worry about the names, guys. All these names, we are going to get into that. If we don't get into all these names today, we'll talk about the names in our subsequent videos. So if you are new on this channel, please, you may want to consider subscribing, because this is the way we are going to be delivering uh, the service, I mean, some of the good uh, innovations and the technology that we have out there. So please kindly subscribe so that each time we jump on live, you'll be able to receive notification, and we'll be able to follow up as we progress, so that you can have the opportunity to ask questions, uh, maybe in a live session as we progress with the lessons. So just a second, I just wanted to check this and make sure, okay, we do not have any question from anyone. Okay, so So I talked a little bit about the deployment. So it allows and then users to be able to define uh, the kind of like define declaratively, okay, the kind of deployment that they will want to run. So they will put everything that they're going to need in the deployment. Talk about the the scheduler, talk about the labels, the match labels, API version, and talk about uh, 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 the name of the application, and just everything. You can have everything defined in that um, deployment. Okay, and you can be able to specify the number of replicas that you want to have, and the number of node groups. Okay, so we are going to see all of that. We are going to see what I'm talking about as we move forward, because we're going to go into a hands-on, uh, uh, right after these few notes. So also we can talk about the service. Okay, so the service in Kubernetes, because let me see right here. Yeah, so some of the things that you hear, some of the Kubernetes objects, one of it is I talked about the pod, I talked about the deployment. So I'm now talking about service. Service also a Kubernetes object. Okay, so it's an entity. Okay, that actually represent a set of pods. Okay, remember a set of pods. A pod is a representation of a set of containers. So you have more. You can have one or multiple containers running in a pod. And while in a service, you can have multiple pods, one or more pods that are running in a specific service. So it says that it is an entity that represents what a set of pods that run that are actually running an application, okay, or functional components of an application. Remember, you can have an application running on a specific containers. Then you also have a functional uh, uh, part of the application, which is usually sometimes dependencies or call it libraries or things that those functionalities that are required to support the application to run, okay, to run without downtimes and all of that. So we will go ahead and then talk a little bit about uh, the notes that we see right here. Okay, you see right here we have the notes. So what are actually nodes in Kubernetes? Okay, so the nodes is just a kind of let's call it a logical collection. Okay, it's a logical collection of of all the IT resources that supports one or more of the containers. All right, one or more of the containers, because right in this node you're going to have ports that are inside this node, and then inside those ports you're going to have containers that are running inside those ports. Take note. So in a node you're going to have uh, 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 ports, and in those ports you're going to have containers. Okay, so right here we have nodes right here, and in these nodes you're going to have uh, pods, and inside those pods you can have containers that are running inside those pods. It can be one or more containers. Okay, and inside a node you can have one or more pods that are running inside a node. So and then communication, okay, between, let's say, uh, the master, or call it the control plane, okay, is being uh, supported and allocated and enabled by the nodes. Okay, so you can see how the node is connected to the control plane. So the network, so the network connectivity is between the nodes and the control plane. Okay, so it contains nodes contains the services that requires to run a port. Okay, that is including communication, network configuration, assignment of workloads. Okay, so a node can host a good one or more ports. Okay, and these components include a container, runtime, and kubeproxy, and the kubelets as well, right? So in this nodes, you can have, like I talked about, containers, runtime, and that's which is sometimes they call it container D, and then you also have kubeproxy, which is right here, and then the kubelet is right here. That is what we're talking about, guys. Then now a little bit about the control plane. So like we talked about the control plane. The control plane is just uh, uh, like someone, we can call it the master controller, right? Everything that happens in the nodes and scheduling and all of that is taking place from within the control plane. Okay, that's why in the control plane you have the scheduler that schedules all the workload that is supposed to run on those call it on those containers or on those or in those ports. Then you're also going to have an etcd. It's just an internal cluster uh, database. Okay, database. So it's call it a storage, and it's a persistent storage. So be advised that with etcd, you will always need another storage, which is external off of the cluster, in order to have your data stored. Because if you do allow your data to be stored directly in all the data and all the resources that are running on the cluster, is if everything is stored on this, on maybe on some of those ports, and maybe if a port dies and it's not being rehealed, then the data, even if it is rehealed, because some of those ports, they'll have data that is running on those ports before they die. So want to make sure that you have your external database. If you don't understand the concept, guys, put your question in the comment section, and we are going to make other videos to also make sure that we explain this concept well demonstrated, so that you get it hands-on. Okay. All right. So in this, we're talking about a control plane. So we're saying that the control plane is just a collection of what? Of it's an administrator. Sorry, guys. So the control plane is an administrator of all activities, and including access, including the management of nodes and workloads, and scheduling of workloads, and all of that. Okay. So this components control, it controls all the interactions between the Kubernetes. I mean, between, it controls all the what happens between Kubernetes and your application. Okay, so you can perform multiple operations uh, via maybe through HTTP. Okay, HTTP based API calls to your application through this control plane. Through this control plane right here. So this control plane is super powerful, and it's worth uh, understanding how it works. Okay, so just hang on and we'll continue, guys. Before we end up, you'll be able to see some other interesting stuff that we're going to go into right in just a minute, which is more of hands-on. Okay, so let's see what we are going to be doing today. Okay, which is deploying your first Kubernetes cluster using an EKS and kubectl commands on AWS, on AWS cloud. Okay, so I'm going to draw a little bit right here, some basic uh, understanding of that, so that we can have some basic understanding of the kind of architecture that we are trying to provision out there. So what is going to happen is, understand that in organization, let's say organization, let's take for example that if your organization is having a cloud-based application and these applications are containerized, understand that if it is in AWS, then it's going to have an EKS managed cluster, an EKS cluster that is fully managed by AWS. Understand that. So it's going to have, I would say, uh, an EKS cluster that is fully managed by AWS for it to be running those applications. Okay, for you to be able to have your containers running on those clusters. So what we are going to have here is I'm trying to design an architecture, a simple architecture, right? A simple architecture of what I'm trying to build out here that we're going to be out here hands-on in just a minute. So you have multiple containers, and these containers, so it's right here. So you have containers that are running in the pods. Okay, they're all running in the pods. So let's say this is so you have, let's say you have a couple of pods here, a couple of a couple of pods, and inside each of these pods there are containers, one or more, right? Let's say inside in each of these pods there are containers that are running in each of these pods. Okay, so you're going to have a container right there. In some cases, remember, like I said, you can have one container, and in some cases you can have multiple containers. Okay, in some other cases you can have multiple containers running in one pod. So this is let's see, bear with me one moment, guys, bear with me please. Okay, let's see. All right, I just want to increase this a little bit so that we can have yeah, so let's consider that these two are separate pods. This is another pod, this is another pod right here. And like I was trying to explain using these diagrams, I was saying that you can have multiple containers running in one pod. So let's see, what are we going to need next? So let's see right here. Yep. So just a moment here, just bear with me one moment. Okay, so if you have you are going to have, let's say yeah, I'm going to grab this. So I want to grab this and put it right here to let you know that these are pods, and in these pods there are containers that are running in those pods. It can be one or more containers that is running in those pods. Then you are going to have some sort of a control plane right here. So this is a control plane, okay? A control plane. Then you as a user, you should be able to control uh, whatever services administer, checking about user authentication to be able to access any of these clusters or be able to do any work or any workload scheduling among the different containers running in the different pods. Okay, and then let's see a little bit of what we're going to be having today. So we are going to also have like a kind of, before you provision an EKS cluster, you're going to need a jump server, right? Using, I mean, when you want to use kubectl. Okay, so you're going to require a jump server. You're going to require a jump server. Yeah. So this jump server is for you to be able to just enable um and make sure that kubectl, AWS CLI, and AWS config, and also EKS they're all running on that jump server. That jump server, it is off of the jump server that you'll be able to manipulate, run all the commands, kubectl commands that are supposed to be run on the master, and also to be in order to be able to for you to be able to communicate with your application. Okay, in order for you to be able to communicate with your application, and that is exactly why we are here today, and it's what we want to show you in just a minute. Okay, all right. If that is it, then we are going to go a little bit hands-on in just a minute, guys. I'm trying to see that we have all of the information that we need, have that understanding before we go hands-on, because I don't want to go hands-on and when we do not yet have all the information that we need, guys. Let me change this to blue. Great. So what I was saying is, if you are a user, then this is let's say you have a user right here. You have a user, let's say, okay, this user, oh, just a moment, guys. I got just a sec. Please let me know if my lighting is clear enough, guys. Let me know if my lighting is clear enough. I just got mess up with my lighting. Yeah. So what I'm trying to explain here, I just want to make sure that we are all getting this concept. We're all getting what I mean here. So if you have a user that is trying to access or communicate with your application from over here, okay, your application is running on these containers, and these containers are inside this pod. That's what I mean here. So these are all pods. Okay, these are all pods. This is a pod, and this is call it P P3. That is pod number 3, and call this one P1. Okay, call this P1. Okay, and you have another pod right there. Call it P. I mean, this one could be P1, right? This one could be P1. Why the other one is P2? This could be P1, and this is P2. Let me do this, and this is P2, and the other one is P4. So these are ports, and you have containers that are running off of this port, one or more containers running off of the ports. And like I talk about the nodes contains the ports. So a node is going to be something like, let me try to draw, sorry. So a node is going to be like external right here, okay? External right here, where in this node, you are going to have those ports right there. And in those ports, you're going to have containers inside those ports. And you're also going to have the kube proxy, the kubectl, and you're going to, and then also plus container D. Okay. So what I was saying is, if you have a user trying to access your application running on those ports, you should, or maybe you want to maybe run a deployment, all of that, and you are using kubectl commands, then you are going to need a jump saver, or call it the Bastion saver. And this saver, call it the Bastion saver. This saver is what on this server that you're going to install, the kubectl, then the EKSCTL, and as well as the Amazon CLI. Then you are also going to give permissions to the server, call it an instance, EC2 instance, to be able to do all the commands and also to be able to access whatever thing that is going on the cluster, and not to be able to provision the EKS cluster. So you are going to have the EKS cluster right there. So this is the EKS. And the EKS in this case is same like the control plane. Okay, call it the control plane. Okay, so this is exactly what is going to be happening, guys. So in this case, you, the user is going to, let me grab this guy. The user is going to be able to access, the Bastion host, and the Bastion host is going to be able to have needs the permission in order to be able to provision an EKS cluster or the control plane. Okay, and also though it's going through this, and then to be able to control the applications that are running on other ports on this on these ports, okay, or on this or on this on those ports, or on the containers inside those ports. That's what I'm trying to say, guys. Okay, so this is how it's going to look like. I'm explaining all of this so that when we go hands-on, we should understand exactly what I'm talking about. Okay, we should be able to understand what I'm trying to explain. So this is the kind of architecture that we want to deploy right now, and we're going to deploy that hands-on. I'll be right back. Give me just a minute, guys. Let me grab some water. Okay, thank you for your patience, guys. Do apologize for that. Okay, let me check this. I just want to make sure that everyone is able to see what we are doing here and can hear us. Okay, let us know where you're watching from, guys, and let us know if you have any question. Go ahead and put a question in the comment section. Should you have any question, put your question in the comment section. Let me go ahead and throw out this link. Okay, I'm trying to forward the link to anyone out there, some other people out there that are trying to understand and watch what we're doing here, guys. So let me see this. Let's see this. Okay. So guys, let's go ahead and get this running hands-on. So before we continue, I'm going to go ahead and give credit to the CEO of Inside Tech. Uh, Inside Tech is one of the consulting um, uh, tech uh, organization out there in California. So we did work together on some of these projects, and so we were able to troubleshoot through some of the problems that we were facing through this, and he was super wonderful in teaching us with some of those problems that you run into, some of the troubleshooting issues, some of the fault, or sometimes you run into some troubles and you're able to troubleshoot all of that. So uh, that way we are going to continue, guys. All right. So to continue, I'm going to go ahead and pull up my AWS account. So whatever thing that we do here is just going to be for learning purposes. And if we expose any keys or access keys here, guys, be advised that we are going to take down the keys right after at the end of the video. So yeah, I saw something on social media. I don't know if it was on TikTok. Someone was like, yeah, I exposed my keys. I pushed my keys to GitHub, and someone used the keys and provision resources in my account, and I received a bill from AWS for like 1,500, and that he was not going to pay. It was pay the bill. I mean, okay. So the first thing we want to begin by doing, want to begin with, is going to be for us to provision a bashing host. Okay, we're going to launch a bashing host. Wow, my system is super slow. I don't know why. Yeah, I'm just trying to close out some of these links. I don't know why my system is so slow. I'm trying to close out some of the links. Great. Okay. Let me see some of the things that we don't need. Some of the things that we don't need, I'm trying to close them out. Don't save. Yep. Okay. So let's go ahead and provision uh, the bashing host. Let me see some of the things that we don't need. We need to close them out, guys. Some of these stuffs are just taking space, messing up. Okay. Shit. Let me see. Sorry, guys. It's super slow on my end. I guess because I got multiple applications running on my timeline, which is fine, right? Let's see what we're going to have. Okay, let's go ahead and give a name to the uh, version host. So let's say that's going to be version host 1. Let's call it host 1. Okay, so that is going to be our version host. And like I said, the goal of having the version host is to uh, make sure that we install all the kubectl on the command line, and then give it permission for it to be able to access the EK and access and provision the EKS cluster. So let's make it a Red Hat. Let's make it a Red Hat machine, right? And we can continue. There are some other ways that we could provision all of that. Maybe going through the Minikube and or the Cube ADM, but it's going to require a lot of configuration. You can also do that manually, right? But it's going to require a lot of configuration, which is what we don't want. So that is why we're taking this route to provision the EKS cluster. Okay, so our machine is going to be a Red Hat machine, and let's see, let's select our security, our key pair right there, and let's see the instance type. Let's pick up an instance type. The instance type, let's take a T2 small so that we can have enough resources. So our bashing host is going to be, like I said, it's going to be a Red Hat, okay, a Red Hat machine, and we have provision a T2 small for the instance type, and then we have our key pair right there. And for security group, we want to go ahead and select maybe any default security group. Let's grab the default security group right here so that you, someone out there trying, that is will be trying to do what I'm doing, should, you can go with a default security group guide. There's no specific configuration that I have right there, and we can go ahead and launch that server. Great. The server has been successfully provisioned. So why the server is provisioning, I want us to look at this. This is let's say let's look at EKS. I want to make sure that we do not have any EKS cluster that is running at this time. Let's check it out, guys. So check out to be sure that there is no EKS cluster that is running at this time. So if you look at that, we see that there's no EKS cluster that is on at this time. And let's look at the instances. Okay, let's look at the instances that are running. I believe we are going to have just the bashing host and 3 other instances that we do have our Jenkins, SonarQube that are running on it. But those other 3 instances, they are currently um, stopped in the stop state. But we are going to have just one instance that's running. This is North Virginia, so but we are in Oregon. We are working in US West 2. So check it out, guys. So let's see. We want to make sure that there weren't some node groups that are already running. So like I said, we have just the bashing host that is running, and it's right here. Yeah, let us know where you're watching from, guys. If you are live with me at this time, let us know where you're watching from, and please kindly subscribe to this channel because we have changed the way our we are provisioning our materials out there. So sometime we'll jump on just live and work live provision um, resources out there for you guys to access it and ask questions. Okay, so please, you may want to subscribe so that whenever we jump live, you should be able to follow up with us. Let's see. Okay, so what we'll do is we will go ahead and connect. Let's go ahead and connect to the command line with this. Okay, so I'm going to use git bash. Oh, let me close this up, and then let's use git bash. So we are connecting using git bash. Okay, so I'm going to ls. Let's see what we have right there. Okay, let's make clear my screen. I'm going to expand this a little bit to make sure that everyone has visibility on what is going on here. So I'm going to cd into my download. That is where my key pair is, so that's why I'm cding into download, guys. So I'm going to paste this right here, and we will be able to access that machine. The machine, the version host that we just provisioned. So we are currently in the machine. The machine is right here. And so you will observe that if we do maybe kubectl, okay, then you see that you say command not found. And if we do kubectl, let's say eksctl, you see command not found, and aws cli, it says command not found. So the first thing we want to do is to make sure that we provision the kubectl. Want to install the kubectl command on this server. So I'm going to, let's go from here and check out for the documentation and see. Let's go for EKS, or let's say kubectl installation. Kubectl installation, and we are going to see that I mean this is for Azure. Let's see for AWS, install and update kubectl on Windows. Yeah, so this is for AWS, right? Installing, so you just google that, right? Installing or updating kubectl on AWS. So let's see. So these are the resources. So you see that right here. I can go right to install. Yeah, this is kubectl installation. So if we roll up a little bit, the machine we just provisioned is a Red Hat machine. So it's a Linux machine. That is why I have choose Linux right here. If it was maybe Mac OS, you want to choose Mac OS right here. But since we are using Linux, that's why I choose Linux right here. And we want to go with the latest version for kubectl installation, right? This is the latest version, so I'm going to copy this one, and we will go right over to our command line. Just 1 second, guys. Let's see who is maybe texting out there. Okay, good. So back on our command line, we will install the kubectl. Okay, so it's downloaded, and I'm going to let us ls, and we'll see that this is kubectl, but we will go ahead and give it executables permission. So I'm going to take chmod plus x, and then we're going to do kubectl. And if we ls again, we see that the kubectl command is now having executable permission. So we want to make sure that everything that we do install, any of those commands that we do install, we will go ahead and move move those files, move the kubectl into the location /user/local and /bin. Okay, so for all the commands that we're going to be installing, we want to move it right here. But if we try to move this one right now, it's going to say permission denied at this time. Okay, so it's going to require, you see that, permission denied. So it's going to require some sudo privileges. Okay, so I'm going to copy this. I can use sudo, but I'll prefer to, let's say, let's become root. Okay, let's switch user to become root. So we are now a root user, and I'm going to paste this right here right now, and it's going to move that file. No, what does it say? It says cannot start kubectl. Let's see ls. Okay, it's not right here right now, so that's fine. That's fine. We can take Control D to exit, and then we can run the command from here with sudo privilege, and it should work. Awesome. So right now, if I do kubectl, we should have that happening. We should have that kubectl. We should have it responding. So it has just responded, guys. Okay. So it has just responded. So it's great. It's working. And the next thing we want to do is to provision AWS, I mean EKS CTL. That's the next thing we want to install. Because if you check out the requirement for provisioning an EKS, okay, look at this. What is an Amazon EKS? So that is it. Then getting started. So let's see, getting started with Amazon EKS. So this is it right here. The documentation is saying, hey, for you to get started with an Amazon EKS, you want to make sure that you provision the command line with the kubectl. Okay, make sure that the command line, it's you have installed a kubectl on your command line. And the next thing you want to do is make sure that you have installed an EKS CTL as well on your command line. Okay, so that is it right here. And right after that, also make sure that you install AWS CLI. So let's go ahead and install uh, AWS uh, uh, EKS CTL. So right here, the installation documentation is right here, and it's in a GitHub. Guys, that's another thing that I did not talk about. It's in a repository. So here's a repo that is in. It's in a WaveWorks EKS CTL. So this is it right here. And what we are going to do is we can copy, I would say, just copy all of this. Yes. So when you get over here, just copy all of this, everything, just copy everything right here. I mean, yeah, just grab everything. It doesn't hurt, guys. Just grab everything, and once you get that, then check out, go to the command line. Let's provision this on your command line. And once you do this, it's going to, okay, let's see. Okay, so let's see that. Want to make sure that the file is there. No, the file is not there. The file is not there because it's a tar file, and the file is supposed to be right here after the you have run the command or the command that you did copied. So, all right, let's see. Okay, so I can go back to the repo, and on the repo, let's see this. Let's see this. Yeah, same thing, right? So right here, I want to make sure that we are on the same page, guys. Just one moment. I'm copying the command. Okay. Okay. So should you want to copy the command and it's not working? I guess there's an amazing uh it's the same command though. It's the same command, but uh the tar file it's going to download in the slash temp location. That is what I was trying to show out to show you guys how it is. Sorry guys, we got this. Okay, so I'm going to go ahead and run the command right here. So with this one, let's see if we got the file. Let's see. No, it's not downloading. Let's see. It's not curling. Let's switch user and see what we have. So we have now become root, and let's see if the file runs now. Let's see. Okay, I'm going to I'm going to go ahead and turn off this command line and go back onto, yes, I have just turned off the command line, and I'm going back into our AWS account to call. Oh, I see why it wasn't able to install, because we haven't signed out of our AWS account. So obviously that is why maybe it wasn't able to download and install that file. So okay, great. So there we go. So this is the instance. I'm going to recopy back the connection command for the instance, and we'll go back to git bash. So I'm going to cd into download, because that is where our key is, and I'm going to paste the connection, and I should be able to sign in. Awesome. So we are signing back on that instance. Great. So we are back on that instance, and I'm going to now switch user. Let's switch user and run the command. So let's see. So the goal here is we are trying to download the EKSCTL file, and then so that we can install the EKSCTL command. So let's see here. Um, let's see yum install EKSCTL. All right. So the file has just downloaded. So it's installing. So I'm able to find a match EKSCTL. So it's unable to find that. Let's see this. Then let's see this then. So let's do ls. Let's see. So the installation is unable to find that file. Oh, yeah. I think we made an error, guys. I know the error. I've seen the error right now. Sorry about that, guys. It's a whole mess. So it's a whole mess. So I made an error when we were trying to copy the command for the EKS installation. We did not, I don't know if we did consider, we did consider that of Linux. Let's see. Let's see what we have. Okay. So, yep, I think it's the same thing though. All right. So if this is not working the way we may want it to work, that's fine, because we are going to go ahead and run this like one after the other. We'll run this one after the other. Let's see what we have right there. Okay. And then the next one, we'll check it out. Then the next one is this. And then we will go ahead and install that. Great. So the file is right there. So we got that in place. So after this, I'm going to go ahead and curl this. Let us curl this repo and grep the platform, and then also check the other one before and check for this. Let's see. Let's see what we have. Yeah, we can just copy all of this with the tar file, right? Let's copy all of this with the tar file, and right after that we're going to move it onto that same location, /user /local/bin. So let's run this. Okay. Oh, it's asking if we should have that. So I'm going to say no. It's asking if we prefer not to have this file here. So I'm going to clear my screen, and I'm going to take a yum install unzip because that file needs to be untarred, untarred. And then we also need to install unzip though, because we are going to install AWS CLI in just a moment. So I'm going to install unzip, yum install unzip. Great, the unzip file has been installed. And then right after this, then we will go ahead and untar the file. Let's see. See, so let's go ahead and untar the file. Let's see. Yeah, let's go ahead and untar the file, guys. The file is this, and we need to untar that file. Let's see. So this file that we are trying to untar is the EKS CTL file. So that is the 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 tool that we just downloaded. Let's see. Let me let's see. Great. So this is the file right here. This is the EKS CTL file that we just downloaded. But it is tarred. The file is tarred, so we want to untar the file. Untarring the file is just going to be for us to tar and then dash xzf then the name of the file eks linux, and then let us tar the file. I'm going to add this now. Let's see. Great, we just untar the file. This is a copy that we just untarred, and we can move the file to the same location. Move eks, that is the name of the file, eksctl, onto the location /user /local /bin. So we'll move that file to that same location. So it's asking if we want to override local /bin that eks. Yes, so the file was already moved in that location. So if we want to override that, they will say yes. Let's say yes. So we just override the file. So let's try now and see if eks command is running. eksctl. We want to see if it's responding. Fail. So it didn't respond. Let's see what we have here. And so do I say I run eks? And it's saying fata. Let's see what we have. Let's see what we have first. Okay, so we were able to untar the file. Then we have to move the file. Okay, oh, we're moving by /temp, right? We're moving /temp. So let's go ahead, untar the file again. So we are going to say tar -zxf, then the name of the file EKS, and that is it. So once we untar this file, I think we should have the file is right there, and we are going to go ahead to move. We are going to move this slash temp slash EKS CTL slash onto slash user slash local and slash bin. So what do we have, guys? So okay, we're gonna have slash bin right there. So slash bin. So we're moving the temp slash EKS CTLs onto that location because that's where you want to have all those files. So they say no such directory or file. Let's see what they have. Let's see what they have. I think it should be slash 10, not slash this one. Let's see what we have. I think it's slash 10, right? Yeah, it's slash 10 because it's root file. It's slash 10. Sorry about that, guys. And then we're moving that with slash 10 right here. Move this to this location. No file, no such file exists. I don't know why they keep saying it doesn't exist. Oh, okay. I see that. I see that. I see that, guys. I did not tie all of this. Remove this. So we want to do this right now. And then we go right here on the command line. So we'll have that. And then we'll say no. And then I'm going to say ls. The file is right there. And I'm going to come back now with this other command. And let's see. Let us I just launched all of this. And then it's just been untagged. Then they want to move this. They want to move that. Let's see. Remove this. Okay, let's see. Let's see what we have. Okay. So it worked now, guys. So it worked. So if we do ls right here, so it worked. So obviously if we do EKS CTL, we should have a response. Okay. All right. Okay. So let's see. Let's go ahead and do AWS CLI. We should be able to. Oh, wait a second. I think there's also permission issues, so we'll take care of that. So let's go ahead and install AWS CLI. And after that, we're going to go ahead and grant permission to the instance for the instance to be able to perform those tasks and provision the EKS instance. So let's go ahead and install the AWS CLI. Let's see right here. So let's see what we have. I may want to use this. Let's use this one. Let's use this one. All right. So we are going to have let's see that, and then we're going to have install AWS CLI. So you see installing and updating the AWS CLI version. Yes, installing and updating AWS CLI version. I'm going to go to Linux. Our system is Linux system. So right here, we are going to copy all of this and install right here, guys. And install right there. So the file has just been downloaded and unzipped. Great. Now you can run the user slash local slash bin slash AWS CLI. So if we want to see that it is working, then we just take AWS CLI version and it should work. It's responding, guys, right? It's responding. You can see AWS version. That's it. All right. Excellent. So now we have all our installation in place. Now let's go ahead and grant let's go ahead and give a user and create a role, create an IAM role that it's going to be able to allow this jump server, this bashing host, to be able to have the right permission that it's supposed to have in order to grant or give access. It's going to give it access to be able to provision that EKS cluster. So let's go ahead. The role, let's call it EKS. Call it the EKS role. Let's give it a role name. Okay, let's call it a role name. Create a role. And this role is an AWS service like EC2, you know, and Lambda. So this is a role that we want to create and then allow the entity EC2 to assume this role and go ahead and provision to assume the role and go ahead and provision the EKS cluster. So I'm going to select EC2. So we will select EC2 and we will click on next. And what we're going to do, we're going to give a full EC2 access, full EC2 access. EC2 permission is full. Let's look, okay. Amazon EC2 full access. That is one of the roles, that is one of the policy that you're supposed to attach to. Then you need an IAM full access as well. So we have an IAM full access, and then we are going to also have cloud front full access. AWS cloud front. AWS cloud front full access. That's it as well, right? This is right here. So you got all the permissions, all the policies that they need, that it needs in order to provision that EKS cluster. So I'm going to say this is an EKS role. Okay. The role is an EKS role, and then you have all the permissions. These are three permissions. The three permissions are CloudFront full access, IAM full access, and EC2 full access. And you can click on create role. So the role is being created. And so while the role is creating, we are going to go ahead and go to the instance, the bashing host instance, and grant and attach that role to the bashing host instance. Let's go ahead and attach the role to the bashing host instance so that it will have the right privilege. It has the access that is. Sorry guys. So that it can have the appropriate permission to give to provision the cluster. So I'm going to select the instance. This want to attach the role. I'm going to select the instance. I'll select the security. I'll select modify IAM role, and I will go ahead and select the EKS role. So I have two roles here. I think I've provisioned one of the rules the other day. So, but this is the role we just created. So I'm selecting the same role so that we can see exactly the role that I'm talking about. So this is a role. We've attached the role right here on the bashing host instance that we created. So we're giving it IAM full access and also EC2 full access and CloudFront full access. And I'm going to click on update. Great. It's fully updated right now. And with this, I'm going to go back to our command line. Let me clear my screen. And from our command line, we are going to do AWS configuration. Let's now configure AWS. Configure. Once we do this, it's going to request for access key. So remember guys, the user that you're using right now, it has access key and a secret key. So just grab the access key and you paste it right here. And once you do that, it's going to ask for the secret key. And this is my secret key. Use the access and the secret key of the user that you logged on with, and you can do this. You can do this. So this is my secret key. And then they're asking me the region where I want to provision this. I'm going to say it's US West 2. Since my instance is in the same region, so I'm going to say it's in US West 2. Since I want to use the instance, I want all the instances, the bashing host plus the node groups that are going to be provisioned should be in the same region, obviously the same VPC and all of that. So, and it's going to say default output format. I don't want any default output format. I could just go ahead and click on enter and I clear my screen. So we now have the access. Okay. Once we have the access, then we can go ahead and create the cluster. So I'm going to go ahead and run the EKS command. Let's see EKS CTL. EKSCTL command. Let's see if it responds. Okay. All right. Great. For details documentation, go to this.io. This is for help about this, that. Great. So it's now is right there. So we can go ahead and do EKSCTL. So we want to provision the cluster now plus the instances, call it the node group, right? EKSCTL create, and then create cluster. Let's see what we have. Dash names dash name. So, and then let's give the cluster a name. The name of the cluster, let's say it's um let's say the name of the cluster is let's just give it, let's say Paul Driver. Let's say Paul Driver. Yeah, so I don't like, I could want to type out the whole command guide, but just for us to save some time, I'm not gonna type out the whole command right here. I have it typed and saved like right here, so that we can just go ahead and use, right? So I'm going to copy this and we can use my name, right? Let's use my name. We can use my name. This guy, feel free to use my name, right? Feel free to use my name when you provision your own cluster. All right. Okay, so it was going to be EKS cluster create. All right. The name of the cluster, the dash name. This is a command right here. EKS cluster, EKSCTL create cluster, and dash name, and then the name of my cluster. I'm going to put my first and last name, and I'm creating the region US West 2, and the node type, I want to make it T2 small. I could make it M5 large, you know, and all of that. It depends on the resources that you want, and we want to say that um, the node, the minimum number of node to be created. I could make it. Let's make it maximum is 4. It depends, right? You can say maximum is 5. It depends on you. Um, let's say maximum is what maximum should we choose, guys? Maximum is 5, for instance. So the goal is you putting this so that you're telling the cluster that each time the traffic is higher, right? Sometimes you have situation like on Black Friday, or maybe right before the Thanksgiving, you start having a lot of traffic that is accessing your application, a lot of purchases and all that online. So when there's that high traffic and you do not have the maximum to be large enough, then it's not going to have that. It can't exceed the maximum that you specify for this node, for the node group, right? So you want to make sure that the maximum that you specify should be such that when it comes to high traffic on your website, accessing, maybe placing orders and all of that, you should have the enough resources in order to accommodate all the traffic, right? So the maximum can be 5 and the minimum can be 3. So, yeah, the maximum is 5. I can make the minimum to be 3. Once the minimum is 3, I'm going to go ahead and we can go ahead and provision the cluster. And that is it, guys. That is it. So you can see the cluster is being built right now. Okay, this is the stack that is being built right now. And is being built, and then the deployment is being deploying the stack is being deployed. So it's going to take a while, maybe some 15 minutes and all that. So it's waiting for cloud formation, right? It's waiting for cloud formation start, all that. So for each step, it's going to tell you what it's doing at that particular time. Then one thing you want to take note of is that you can see from here that right now I have just one instance that is running, right? One instance. This is just one instance that is running and is the bashing host. So it's going to provision for us three clusters. Remember we said minimum should be three node groups, and minimum and 5 maximum. So it's going to give us 3 instances right here. So if you stay right here and watch, it's going to, you'll see 3 more instances are going to start initializing right here. Okay, so it's automated. And if you also look at the the EKS cluster, the EKS cluster, you shouldn't see any EKS right now. So, but with that, very soon it's going to give you the EKS. So it's building, it's not yet there. So we're gonna keep refreshing and watching. Soon as very soon we're going to have the instances that have been provisioned. So let's check out for the EKS. Let's see. Let's see the EKS cluster if it's been provisioned already. EKS is the Elastic Kubernetes service. Let's see if one is already being, let's see if the stack it's already available. It's going to take a while, guy. Okay, you see that? So you see the EKS, you can see like right here, the EKS right here is creating, right? Creating. So if you don't do this automated, guys, if you do this like in a manual way, it's gonna like take you a lot of configuration. But with this automated nice and automated fashion, it's gonna provision for you. The EKS cluster is being provisioned, and is creating right now, and the instances are also going to be creating in just a moment. It's automated. Okay, it's automated. The instances are going to be provisioned in just a moment. Let's just watch the instances, because when you do this manually, you can do this. It's going to take you a lot of time, and it's going to give you a lot of errors, and you are not sure of the configurations. Okay, and let's see, you can also see the auto scaling groups. It's also going to create, it's going to be created once the clusters are all the instances are all provisioned, and the cluster, you're going to see the auto uh, scaling group, and you can see the launch configuration as well. The launch configuration is going to be here in just a moment, and we can come back here and see the launch configuration. Okay, and when this happens, some of the questions that you may be asking yourself is, what about the IP addresses, IP address for the instances, right? So it's going to auto provision an elastic IP address as well. Okay, it's going to auto provision. Great, this is the elastic IP address right here. It's already provisioned. It's just been provisioned. This is a elastic IP address. So this is to tell you that there's not going to be any downtime, okay, in US West 2. And you can also see the network interface, right? You can see the network interface. Let me see. Let's look for the network interface. It's going to provision network interface. These are the network interface right here. Let's see. I want to be sure that the network interface is just being provisioned. Let's see. Yeah, let's check in what subnet is it and see that it's the same subnet. Okay, yeah, it's just been provisioned, right? It's just been provisioned and attached to the Elastic IP address and also the instances. So I think that in just a moment, so this is the VPC, this is the EKS cluster that is being provisioned. Let's see if it is if it is completely created. It's still creating, guys. So if we go back to our command line, we'll see. You see, so it's waiting for the CloudFormation stack. So once it's created, the instances are also going to be there. And so why it is provisioning the instances, we can go ahead and create our and write our deployment manifest file while waiting for the cluster to be provisioned, right? For the clusters to be provisioned. So let's go ahead and write our deployment manifest file. Oh, we can't write this right here though. We can anyway, but we can uh, also open another terminal. We can open another terminal for the same instance, and we write our. So I'm going to go ahead and copy. Let's go ahead and copy the. Okay, I think it's almost done though. Okay, it's still creating. So it takes a while, guys. It takes a while. So yeah, let us know in the comment section, guys. Uh, let us know in the comment section if you how you've been able to provision um, your EKS cluster. Is this the same way that you provision your EKS cluster in your organization? Let us know, guys, what you do sometimes to provision your EKS cluster. Do you do this the same way or you do your configuration manually? But I understand in most organizations, before you join some of the organizations, all this configuration would have already been done. But let us know from the old folks out there if it's the same thing that I've been doing. Go ahead and put in the comment section. And I mean, yeah, in the comment section, and I'll be more than happy to see that, guys. Let me see just a moment. Okay, yeah, in just a moment, the instances are going to start creating in just a moment. Yeah, so let's be patient. We are going to have the instances right here in just a moment. Let me see. Let me copy. Let us connect and start writing the manifest file. Yes, guys, please, if it's your first time on this channel, please consider subscribing and please kindly share with anyone, your loved ones that are maybe into the tech space as well, or who are also using the Kubernetes, or maybe who are maybe using it, you know. All right, let's go ahead and connect. I'm going to cd into my download again because my download is right here. Wow. Okay, let's exercise some patience, guys. I thought I could possibly just go ahead and connect and be able to start writing, for us to start writing the manifest file, right? The Kubernetes manifest file. Anyway, I could just write it maybe on let's say on our OneNote, right? Let's go ahead and take our OneNote. Go, let's say Notepad. Yep. So we want to start writing. Let's go ahead and write the deployment manifest file so that once it's complete, the provision of our instances and our EKS cluster, we can deploy, do our deployment, how you can write your deployment, right? How you can create your deployment, okay? So the file, we're gonna say, let's comment, right? Want to create, like, want to institute some best practices. So create a deployment, right? So want to create a deployment, and the first thing that we want to do is always our API version, and our API is always write our API version, and let's say our API version, it could be application, or let's say it's a web app, or let's say the web is sorry guys, I just messed up with my. Okay, sorry about that guys. So this is our API version. So I'm gonna say dev. Okay, we can say it's the version is Power App. Let's say it's V1. Okay, let's say it's just give it the name of the application, the version. Let's say it's version 1. Okay, and then the next thing we want to put in place is the kind, right? The kind is deployment. Okay, remember you can write uh, the kind sometimes can be service. You can also create a service. You can create a manifest file for deployment. You can create a manifest file for pod. Okay, so and all of that. So the kind is deployment, and then The next thing you want to write is the metadata. The metadata. So with this metadata, the metadata has subcomponents, right? I'm going to increase this. So we want to create a deployment. So the metadata is going to be having some subcomponent, and one of the subcomponents is going to be what? It's going to be the name of the deployment. The name of the deployment, can be uh, pulse dash app pulse dash app deployment, right? Deployment. So that's the name of the deployment, and we can have labels, right? That's the label can be the labels. Let's do some labels right here. The labels can be, let's say, the app, and uh, let's say apps can be what? Let's say it's pause app. Okay, let's just do that. Pause app. It can be pause dash app, right? Pause, pause app. Okay. Yeah, because the application is pause app version 1. So let's say it's going to be pause app. Let's see, I talked about version 1 here, but I was writing something different. So the application is pause app, and then what are we missing, guys? So when we have the API version, we have great. So as you can see, guys, the nodes are being provisioned right now, right? So the nodes are being provisioned right now. You can see right here, nodes and the IP. Okay, it's been completely provisioned. You see that? So you see this tick right here. The tick right here shows that the cluster is ready. You can see that. And we can see, let's go over to the, let's go over to the account, and you'll see that everything has been provisioned. Let's see the instances. You'll see the instances that are running right now. You see 3 more instances has been provisioned. We say minimum should be 3 and maximum should be 5. So it's 3 right now because we haven't host the application on it already. So when we host, if we do host applications on it, on this, and it start, maybe when uh, they start accessing the application, and you see that they start accessing the application, and obviously they should, and resources, maybe as the traffic increases, they will start, it can add another instance when the traffic increases, and when the traffic is less, then it will reduce the number of instances to a minimum of 3, right? And when the traffic is high, it will increase the instances to a maximum of 5. Okay, and when its traffic is low, it reduces the instances to a minimum of 3. So that is it. So these are the instances that have been provisioned, and then the EKS cluster is right there, and then we can have the auto scaling uh, uh, configuration right here. Okay, this is the auto scaling. So you can see from here, it says the desired capacity is 3. Okay, you can see right here, it says the instances that has been provisioned is 3. The instance that has been provisioned is 3. The desired capacity was 3. which was minimum we requested for minimum of 3, and then the minimum was 3 and the maximum is 5. Okay, so you can see that clearly from here. And you can also check the launch configuration. Is the auto scaling group is still the launch configuration. You can see, I mean, under this auto scaling group here, it tells you all the launch configuration though. And then we have an elastic IP address was there already. And then you can also see the network interface of that. The network interface is right there, right now. This is the network interface right here. Then I want to see the load balancers. Let's see if it has the load balancers. Okay, no, it doesn't create one, but it's the EKS cluster takes care. Let's see if okay, network interface is there, the volume is there. I mean, what? So everything looks good, guys. Everything looks good, right? Everything looks good. So let's go ahead, complete complete our deployment manifest file. Then go ahead and launch our deployment. So the next thing is specs. The spec, under spec, we are going to have specify the number of replicas. The number of replicas is let's say three replicas, and then we want to also make sure that we specify the selectors. The selector is right there, and then under the selector we need to be able to talk about the match label, right? The match label. For the match labels, remember guys, under the match labels must always be the same with the labels. Okay, so under the match labels, just come over here, copy this guy, and you can always put it right here. And that's it for the match labels. And for the template, I think there's nothing much, but you can have like the templates, right? Then the templates is under the same thing, like that is a deployment template, right? The template is always right below the selector, like same thing like the selector category. So right under the template, we can always have under the template, remember you have metadata, right? The metadata again. So metadata is just fine. And then we can also have, let's see, we want to make sure that everything looks good. Yep. Then we can have under the template, we can have a label. I mean, not under the metadata, we can always have labels, right? Labels. And then under the labels is the same thing, right? Same thing from right here. The same thing like right right here. So it's same thing like match label, right? So under the metadata, you can have template, and under template you can have this. So I'm going to put it like right under metadata, and I'm going to have, I just miss data right here, and the app is going to come right in front there. Perfect. And so let me see if I'm missing anything, and then we can still have let's say the spec right under the template you can have the spec. The spec will come like under the metadata right here. Let's say the spec, and under spec we are going to have um, let's say we're going to have the containers, right? Let's define the containers, and then with its own specification. Under the containers, we want to give the container name. Let's see the container name. The name, we can say the container is let's say blue, right? Let's call it blue. Um, then the image. For the image, I'm going to go ahead and we will log into our Docker Hub and grab an image from there and use. So I'm going to go ahead and go into our Docker Hub because we have customized images that we've been building and put in our Docker Hub. So that's the same thing that you would be doing right on the space, guys. Always make sure you have customized images for security concerns. Security concerns, very important. Take security issues seriously, very seriously, guys. So I just log into our Docker Hub right here, and we have images that we built and we've put right here, and you can pull them and use as you want, right? So I'm going to copy. Let's use the one with Nginx. This one, okay. Let's use this one, Nginx. Let me see this. Yeah, let's use Nginx. The one, no, no, Nginx, those are the names are a little bit common. Let's say that's we're trying because we want to make sure that the security best practices, okay? Security best practices is always at the top. It should be like job zero for you guys. Okay, so for the image, we are going to use, let's use image. Let me use, I'm going to use Paul. Just a moment, guys. Just a moment. I want to make sure that we are having visibility on what is happening. When you clear this up, yep. So, but we'll be right back there in just a second, guys. So for the image, we are going to have Paul Leffer slash, we have an image out there slash ng. That's an image that we have out there. Okay, slash ng. Then um then the image pool policy. Okay, we need to have the image pool policy. Image pool policy is like, you know, each time uh, since you are going to have an automated uh, kind of scaling, right? Automated scaling, so it should be able to pull the images, the policy for the pulling of the images should be always, right? Always. So that if it is restriction, if you have restriction, then obviously you won't be able to pull the image. So the image pull policy is always. So that is what you have. That's what we'll have. And then, what about the ports? Let's go ahead and put the port, right? So we are specifying um, the port, all right? The port that we want to expose. The port, all the ports that we want to expose right there. We can just have that right here. And I'm going to put that, and we can put the container port, the port I want to expose for the container, right? The container port is going to be 8080. Okay, that is it for the container port 8080. And then um, let us specify the strategy, the deployment strategy. Remember, we have 4 deployment strategy. You have the rolling update, which is the default the default deployment strategy, right? The default deployment strategy is a rolling update. Then you also have recreate. You have um, the blue-green deployment strategy, and then you have the canary deployment strategy. So in this case, we are going to use the strategy. We are going to use um, rolling update, which is the default deployment strategy. Rolling update, recreate, the blue-green deployment strategy, and the canary deployment strategy. Okay, so uh, it will always depends on any specific situation that you that is going to, you can best make a decision as to what strategy do you want to use, right? You have any question about that, please go ahead, you put in the comment section, and we do way to answer your question. Rolling update, that is a deployment strategy. Rolling update, and we will go ahead and have a rolling update right here. And then let us now go and put the maximum search. This maximum search right here is simply saying that if it is the rolling update should be such that it's replacing a maximum of 1 uh, container at a time, right? Okay, so a maximum of 1 container at a time. So you are saying that for one unavailable, rolling update, that is rolling update the deployment such that uh, create one unavailability, one unavailable, and then one available, one unavailable, one available. Okay, so that there shouldn't be any downtime, right? So that there shouldn't be any downtime, because if you want to say you want to go 3 unavailable, then 1 available, then you want to create downtime, which is unhealthy for the application, which is unhealthy for your platform. Okay. All right. So let's see. I think we got all we need. If you feel like anything, we're missing anything, guys, please let us know in the comment section. And then if you have some other additional information to add to this, then we'll be more than happy to learn from you guys as well, right? So I'm going to copy this and we're going to sign back onto the instance. So we are back on that instance. So this is still on the bashing host. So we want to be able to run this kubectl command on that. All right. So we are going to access the platform from this our bashing host. So I'm going to do let's do a couple of things, but before that, let's do sudo su. Let's switch our user. So we just switch our user, and then I'm gonna do uh, AWS CLI, AWS CLI, sure, responsive, right? It's responsive. And we can do AWS EKS, EKS. It's fine. It's fine. We can do. Let's begin. Let's do kubectl, kubectl um, get get all. Let's see get all. I expect that this should not respond if. Okay, great. It's responding because I was concerned with the security group, right? With the security group. So I thought that the security group, all these ports were not open. I thought they weren't open. So if they are not open, then obviously we will not have this right here. So you can do kubectl get nodes. So we see that we will see that we have 3 nodes that will be running. Get nodes. Let's see what we have for the nodes. Yes, we have 3 nodes that are running. They are all ready, right? Then they were launched 22 minutes ago, and then the versions are right there. Version 1.25.7, and the same version with the EKS, right? So it's provisioned by the EKS. So let's see if we have any ports that are running. kubectl get ports dash, let's say n dash. Let's if you do kubectl get ports, if you just say ports, we shouldn't have any port. You see, no resource found, right? Because there's no port that is running right now. But you can see that we will have n dash what cube system, right? Cube system, cube n dash cube, I mean dash n, then cube system, cube dash system. Okay, so let's see what we're gonna have. So these are a couple of ports, right? So this is by default, right? Remember, cube system is one of the default namespace, one of the default namespace that we will have when that is being provisioned by default, right? And remember, we have 4 default namespaces. So cube system is one, and so that's why with cube system we can see a couple of these ports that are running, and then so right now what I was trying to do is we wanted to create that deployment, right? We want to create that deployment. So with the deployment, we are going to say, let's create a VI and they say deployment. And it's written in YAML, guys, okay? It's written in YAML, declarative, okay, .yaml, let's say .yaml. Okay, deployment.yaml. So we want to create that deployment file, right? Let's paste it right here. Oh, oh, yep, I'm supposed to go into insert mode. Sorry about that, guys. We just messed it up. For real? Okay, let's exit that. Let's exit that QA. So let's see, no right since that. Yep. Let's exit that again. Yeah. Come on now. QA and that. Okay, perfect. So let me see if the deployment file, okay, wasn't created. Great. So we're going to say vi. Let me copy this one again. I think we had this, right? Into deployment.yaml. And that's it. Then we go into insert mode and we should be able to paste this right here. Yep. I think everything looks good according to my observation. And let's go ahead and save this. Come out. The file is right there. And we can do a kubectl apply. So this is how you do your deployment. Okay, kubectl okay, kubectl, then we have deployment apply, then we put the name of the deployment file. Okay, kubectl deployment, then we put apply, then we put the deployment file. Okay, let me see. Let's see what we're gonna have. Let's see. Up, unknown error. Okay, deployment for kubectl. Okay, I think it's supposed to be apply deployment. Up, deployment. Yep. Let's see. Deployment. Let me see. CQC apply dash H. Let's see. kubectl apply. Oh, sorry guys. So I was supposed to take the word deployment is not supposed to be there. I just sometimes you miss these commands, right? It's crazy. Kube is supposed to be kubectl dash F, right? kubectl apply dash F, and then the name of the deployment file. And so it says error processing the YAML file dot this error converting YAML to JSON. And then YAML line 21. Mapping values are not allowed in this context on line 21. So let's go ahead and VI into the deployment file. So, okay, so values are not allowed on line 21. So we're going to go ahead and go into insert mode. And we will look at that. Let's see what happened. What happened? Yeah, so we can, let's see. I can correct this. You can correct this. Let me see. Let me see if I can auto correct that. Let's check for auto correct. Sometimes it's nice to also read through that before you look out for correction, right? But it's also nice if you have an option that you can auto correct the problem, right? If you can auto correct the problem, it's also great. It's a great thing, right? So let's see, I have an auto correct tool, right? Auto correct. Let's see this. Let's see what I'm going to have. An auto correction and see. Let's see. Let's see. Yep, this other tool. Just a moment, I'm trying to troubleshoot this particular error. So I'm trying to see what is wrong with this. Let's see. What we're going to have. Let's see what I have here. Okay, I think we are good. Let me see what is wrong on this line 21. Okay. Let me check the image. The image, I think that the image name, we did log in here, right? This is the image name right here, and the image name is correct. Okay. Okay. Ruling update is correct, and the port is correct, 8080, and the pause app. Okay. So I guess this should work without any problem right now. Let's see what I got here. Yeah, there are ways that you can auto delete all of these guys. So yeah, I've forgotten some of those ways. I think we just control, I don't know, it's control F or control something. Please let us know if you have an idea on how we do auto. Okay, sometime I would just step out and then delete the file and create a new file and then just paste it rather than going through the auto delete process. Yeah, I think one other thing that can stop this file from running is access to the access to be able to uh, pull that image. I think that may be the case also. Then we'll go ahead and run our command again. Okay, great. So it was able to successfully pull the image from Docker Hub, and it was able to create the deployment, right? So that's awesome. So let's see the deployment. Let's see kubectl get deployment. Let me see ctl get deployment. Let's see the deployment. So the deployment was created, right? The deployment was created. So it has deployment was created with that's 39 seconds ago. Availability is 0, and then up to date is 3, and then you have ready is 0 of 3, right? So nothing has been updated, right? And but it's available, is capable of doing a rolling update. Okay, so it doesn't done anything. So we can see a couple of ports now, right? qctl get ports. Let's see the number of ports that we have right now. Yeah, so it's clear we have 3 ports that are ready. I mean, it's not running, right? It's not running right now. Um, you see, initially without this deployment, we couldn't have these ports, right? But with the deployment right now, we have been able to provision these ports that are available right now. And it's based on our specification, right? It's based on our, that because we did said we wanted this deployment with 3 replicas, right? With 3 replicas. So let's see the number of nodes, because if we change the replicas to 5 replicas, then we'll be able to have 5 ports. 5 ports. Okay. Yeah, we'll be able to have 5 ports. And understand that in these replicas, there are containers. Okay, so there are supposed to be containers that are running in this port, right? So it can be one or more containers that will be running inside these ports. Okay, so we have the ports right here, and then they are ready, but it's not running right now. Okay, restart 0, so you can restart these ports and all of that. So that's it, guys. Let's see the number of nodes that we have now. Nodes. Let's see the number of nodes. We have 3 nodes. Yeah, this one were the one that were provisioned right after when we did provision the EKS cluster, right? So that's what we have. Then looking at this, we can describe. Remember, we can describe the ports or the nodes. We can describe all of that, and yeah, so everything looks good, right? Everything looks good. So in order not to make this video to be too long, guys, we are going to stop here for today. And please kindly subscribe, and we will continue with part 2 of this video. With part 2 of this video, we are going to uh, uh, run other, create more deployments, modify. We are going to modify this deployment because we can modify this deployment right now, right? And change the number of replicas and and go ahead, change other things like uh, the number of maximum number of search, and we can change just so many things, right? And do our, so that we also do that configuration, get our containers running, and then we can have so that we can be able to access our application. So to show you exactly how we can be able to access our application. Right now, there's not going to be any downtime with this, so it's great, right? And that is a role why we use Kubernetes. That's some of the interesting reasons why we use some of the powerful things that Kubernetes will be doing out there. There are other interesting things I want to show us here right now, but because we don't want the video to be too long, please kindly subscribe, guys, and we will see you next time. Thank you for watching. Goodbye, guys.